All right, so we are almost done. I got a little cut off here. So with relative min, I didn't get to really talk about that. So I pointed out, I believe, that this was our relative min spot. It's the bottom of the valley. And again, when we write it, we're referring to where y is the smallest value. So we write it as the relative min. All right, so there was one of those barking dogs. So we write it as the relative min of, and then here I don't put the y, I just say what the y value is of -2.5 when x equals 1. All right, a few more things to talk about. One is, this is also new, it's called the end behavior. So in the end, what is your graph doing? So over here, this is an end behavior, and over here, this is an end behavior. So whatever the graph is doing all the way on the left and on the right as well. So unfortunately, we are going to have to write this out. So right now, you would have to write this all out. You would say LIM, and this is a thing for next year, this LIM, but what we're focusing on is, all right, as x gets bigger and bigger and bigger, as x approaches infinity, which is this side, because over here, when this arrow is going to the right, that's when x is getting bigger and bigger and bigger. So we're saying as x gets bigger and bigger, what is f of x? What is the y doing? Is it getting bigger or is it getting smaller? So remember, we had said, this is x is getting bigger since it's going to the right, and x is getting bigger since it's going up. So I've kind of already addressed this as x is getting bigger. What I want to write is, well, what's y doing? What's f of x doing? And so this is what I would write. Now, in this one, we're looking at the other direction. Well, what happens when x is getting smaller? And over on the left side, this arrow, as we had already said, indicates it's going left, which means your x is getting smaller. And so what we want to know is, well, what's the f of x doing? What's the y doing? And so as it goes left, negative infinity, it's also going down, so negative infinity. And this is what we would put in here. So let me put these two in here. All right, domain. This is review. What we want to know is, what is the domain? What are all the x values here? So if we go back to one of our other graphs, so, we had this written down. We had our max and our min. We had our x-intercepts. So let's write some of those down. 4. And what did we say? This was like -3 and 2.5, and we said this was about 1 and -2.5. I'll wrap some parentheses around these ordered pairs or coordinates. So what we're looking here is, in this whole thing, what's the smallest x we ever wrote, and what's the biggest x that we ever wrote? And again, we're going to use this interval notation, the smallest value and the biggest value. And so when I look at all these x values that I wrote down, the smallest that I ever wrote was negative infinity, and the biggest x I ever wrote was infinity, and we will put parentheses around those. And sometimes they will be numbers, but not in this particular example. And then for range are all the y values. So again, I want to write what's my smallest y value, what's my biggest y value. And for sake of time, I'm not going to rewrite this. So x, you're just kind of looking left to right, smallest to biggest. With y, you're looking from smallest y to largest y. So you can think of it as you're scanning from the bottom to the top. And the smallest y, oops, I missed one, that I wrote on all of these was negative infinity. And the biggest y I wrote was infinity. And again, we always wrap with interval notation with infinity signs. We use parentheses. And there's one more stretch. So we had increase and decrease, but there's also where the y value is constant, where it remains the same. So remember, this section was increasing. This section is increasing. Again, I read left to right, but this section, this is constant. So what I want to know is, where was the function constant? And again, I don't want to use the y value. So if I look at this point, this is -1, 1. And if I look at this point, this is 1, 1. And so I want to know, where did that constant start and where did it end? So again, I'm going to use the x values. It started at -1 and it ended at 1, this one. I'm not going to use the y values because then again, those are the same and it doesn't look like I have a start and a stop, a small number and a big number. So we don't use that one. And just like with increase and decrease, I'm going to use parentheses because at this point, it's not increasing, but it's not constant. It's just kind of like there. And then the same thing here. So we will use parentheses. And again, most time it will be parentheses. All right, we got about 2 examples, and then you'll have some more practice. So the first thing you should do is always mark and label your key points. So any turning points, the top of the hill, the bottom of the valley. So here, here, and here. And we're going to estimate these points. So I think this one is about 3.5. And if this is -50, these are going by 50s, right? So this might be -125. Again, that's just an estimate. This point, I'll say it's about a half. Or -1/2, sorry, and let's just say maybe it's at about 40. And then this one we'll say is at -2.5, and I don't know, maybe it's at -10. Again, these are just estimates. Let's put some arrows here. So I also want to do my x-intercepts, so let me find a different color here. So here's an x-intercept, that's at -3 and 0. I got another one here at -2 and 0. I've got one at 1 and 0 and one at 5 and 0. And then I want to get my end behaviors. So what is this arrow saying? Well, it's going left, so left, right. Left is -infinity for x, and it's going up, so up is y, and that's infinity. And then over on this arrow, it's going to the right, so left and right. Right is bigger. And it's going up, so up is bigger. I'm going to write that. All right, so I got my turning points, my x-intercept, and my end behaviors. If I write these once, I never really have to think about them again. So let's start with domain. Again, domain is the smallest x to the biggest x that I wrote. And when I look left to right, the smallest x was -infinity, the biggest x was infinity. Another thing you can write, remember it's parentheses, is A, R, N, all real numbers. Because we're focusing with real numbers. There's another type, imaginary, those will come up later, but everything we're working with right now is a real number. So if you don't want to write the infinities, you can write ARN. So for range, I want my smallest y and my biggest y. So this time I'm looking for bottom to top. So when I look, my smallest y is actually -125, and my biggest y is infinity. So always parentheses there, and this time I'm going to put a bracket because -125 is actually one of the y values. It's not close to it. It is one of the y values, so I want to include it. And behavior, again, this LIM is for next year, but we're looking at, all right, if x is getting bigger, what is that f of x is doing? And some people might use an arrow. You can also use an equal sign. It's up to you. So as x is getting bigger, well, what are the y's doing in the end? Well, they're getting bigger. And then I write it again, just get a different color so you can see that you will always have 2 of these. As x is getting smaller, what are the y's doing? And that's over here. As they're getting smaller, the y's are going to, and this time I wrote an equal sign. You can do an arrow, really up to you, an infinity sign. Okay? Always make sure you do 2 and make sure that they're written appropriately. All right, this is review. If x is 5, that's what this means. What is the y value? So I want to go to where x is 5. X is going left or going right. So I'm going to go right to 5. And when I get there, I'm actually on the graph. So I'm going to say my answer is 0. Let's go for our increase. And then even though it's not next, let's go for our decrease. So I'm going to highlight some of these. So I know that increase I'll put with an I and decrease I'll put with a D. So let's see. I thought I had a different color here somewhere, but maybe not. Yeah, I do. Okay, so right now, left to right. Even though there's this arrow, left to right, this is a decrease. Then it gets down to here, and then it starts to increase till it gets to here. Sorry, you can't see that. Then it starts to decrease till it gets to here, and then it starts to increase. So when I look at my answers, I'm going to have a decrease section, an increase section, another decrease section, and another increase section. And again, I don't do all the increase, all the decrease. I bounce back and forth between the two. So I'm going to start with the decrease, and we always use the x value. So it starts at negative infinity, and it decreases till I get to the bottom at negative 2.5. Always parentheses. And then it increases. So where it increases is the negative 2.5 until I get to the top, which was this negative half. Again, always parentheses. And then it starts another decrease. Again, it starts at that negative half and goes until I get to the bottom, which is about 3.5. And then there's another increase section, and I start at 3.5 until I get to the top, and I'll put infinity. Now let's do the positive and the negative. So starting left to right, get my markers. I want positive in pink. So it's positive until it gets right there at that x-intercept. Then we got a little negative stretch, little bit there. And then I got another positive stretch. And another negative stretch. And another positive stretch. So just, again, I'm going to go from one to the other. So I'll start with whichever one came first. So my positive stretch, so again, here's pink, yellow. So pink, I've got one positive stretch, then I got a little negative stretch, then I got another positive stretch, another negative stretch, and one more positive stretch. So let's start with our positive stretch. So it starts at negative infinity, again, until we get to that x-intercept, negative 3. So positive negative infinity until I hit the negative 3. And then it becomes negative. So from negative 3 until that negative 2, it's in negative interval. And then from negative 2 until I get to 1, that's positive. Remember, I'm only using the x values. And then another negative stretch, so it starts at 1 and goes till 5. And then I have my last positive stretch of 5 to infinity. And again, always parentheses. And if you want, I don't care about this. Again, we can put this is a union. It means there's more than one. Oops, I didn't leave a lot of space, but don't feel much pressure there. All right, are there any maxes or minimums? Yes, we got a minimum, we got a maximum, we got a minimum. So I'll just do them as they go left to right. So we have a minimum of negative 10. We state the y value when x equals negative 2.5. And then we have another one. We have a minimum of, or maybe you want to say at, negative 125 when x is, you don't have to say equals, 3.5. And then, whoops, I switched these around, just realized that. So I'm going to change this to min, and now here's my max. And I have one maximum value, so I have max at 40 when x is negative half. So sorry, I wasn't reading very carefully. And finally, my average rate of change. Again, this is the x value that we're starting at, so we'll need its y value. And this is the x value that we're starting at, so I will need its y value. So at negative 4, it's about here, so why don't we just estimate that to be about 100. And then where x equals 1, sorry, you can't see that, we're at 0. So again, it's just slope. I'm going to subtract the y's on top. So 100 take away 0, 0 take away 100. I'll do this. And since I'm doing 100 take away 0, I'll have to do negative 4 take away 1. So I get 100. I like to do this where I add the opposite. To me, I like adding more than subtracting. That's negative 5. I divide them. And you always want your average rate of change to be out of 1. A rate is always out of 1. Okay, and if you get a decimal, that's okay. All right, last one. All right, so we're going to put some arrows here. We're going to mark those end behaviors, all those things. So this arrow is going left. Left is smaller, and it's going up. Up is bigger. This arrow is going to the right, so bigger, and it's going down, smaller. I want my turning points, so I got this one, that's 0, -2. And I've got this one, which is 2 and 2. And my x-intercept. So this is about, I don't know, let's say it's 0.75 and -0.75 and 0. This one is at 1, 0. And this one, it's about 2.75, 0. Usually I try to stick to halves and not 0.75s, but oh well. All right, domain. Those are the x's. Smallest x to biggest x. As I look left to right, the smallest x I wrote was -infinity. The biggest x I wrote is infinity. So again, you can do this. You can also use all real numbers. My range is the smallest y and the biggest y. So when I go from the bottom, the smallest y that I wrote was -infinity. The biggest y was infinity. Or again, you can write all real numbers. End behavior. In the end, what's the graph doing? Again, LIM, that's for next year. Under it, you put the x with the arrow, infinity. So as x is getting bigger, you know, what are the y's doing? What's f of x doing? And it's also getting, smaller. Not paying attention. I was looking there and not there. And then I write it again. All right, as x is getting smaller, what's my graph doing? What are my y's doing? And that's over here, and I would say it's getting bigger. And you can put this one first and this one second. That doesn't matter. All right, increase, decrease. So I and D. So left to right, we start out with the decrease section till we get to here. Then we have an increase section till we get to here, and then we have a decrease section. Whoops. So for increase, I'll have 1, and for decrease, I'll have 2. So where does it start? Where does it stop? I'm going to put my second one. So let's start with the decrease. Use the x value, working our way till we get to here. It goes from -infinity to 0. Again, always parentheses. And then we have an increase stretch, so it goes from 0 to 2. Always put parentheses. And then it decreases from 2 to infinity. All right, negative and positive. So this is where the y's are positive. Did I switch that? Nope. And then negative, because negative is supposed to be in yellow. And then another positive stretch. All these y values are positive. And then we have another negative, which is in yellow. So let's see. Negative, we got positive first. So 1 positive, we got a negative, we got a positive, and we got another negative. I always like to fill them up or get them set up. So let's start with our positive. It starts at -infinity until we get to this x-intercept, which I don't think I put that one on there. Oh, yeah, I did. It's right there. So we're going to say it started at -infinity until it got to this -0.75. And then we start with negative, so we pick back up at the -0.75 until we get to 1. And then we have another positive stretch from 1 until we get to this 2.75. Whoops, almost put on the wrong one. And then we have our last negative stretch of 2.75 to infinity. Almost done. All right, a max and a min. We got one of each. So first, here's our max. So there's a max of, at, when, no, of or at 2 when x is 2. And then we have a minimum. We have a min of, oh, there's a dog barking. Hold on. All right, so we have a min of -2 when x is 0. And the last one, another average rate of change. Again, when x is -4, we'll need its y value. And when x is 1, we will need its y value. So -4, you know, we can't see it on the graph. So we're going to show you a different way to do that. But when x is 1, right there, we do have 0. So what are we going to do when x is -4? Well, what I'm going to do, if I can find it, all right, I'm looking for my calculator. I'm going to pause you. oops, I'm actually going to use the equation and input -4 into my equation. So I'm going to first put the negative that they have, and then in parentheses, I'm going to put -4, so it knows I'm taking -4 to the third power, plus 3 parentheses -4 to the second power, and then -2. So can see it on the graph, we're going to have to put it here. And I get 110. So there is my y value. All right, y is on top. I think it's easier to do 110, take away 0, which means I'll have to subtract, the same way. So -4, take away 1. That's going to result in 110 over -5. And when you divide those, great to use a calculator. Again, it's -22 over 1. Rate of change is always over 1, so make sure you get your calculator and divide if you can't do that division in your head. All right, that was a long video. So what is your practice? Your practice is on page 13. You're going to write these as intervals. I do expect to see the I, the yellow, the D, the pink. This I don't need for you to do, but it would just be like, here's my max, here's my min. I think our graph might get a little overwhelming. If x is -3, what's y? If y is -3, what's x? What's your domain, the range? And remember the end behavior. You got to write this. If you don't write this correctly, it's wrong. So I don't care if you put an equal sign or an arrow, and then you have to do it again with a negative infinity. Based on what you see here, I want you to tell me if this was increasing, decreasing, positive, negative, or infinity, infinity. So these are these points right here, okay? And I do expect you on all of these to label your key points. So the end behaviors, put arrows there, the turning points, the x-intercepts. And if they're already marked, then don't rewrite them. And is there anything on the back? Nope, that is it. Thanks for tuning in. That was a long video, I know, I'm sorry.